Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P. You are given that x and y have a joint distribution with density f sub x y of f sub xy of xy equal to e to the minus x plus y for x greater than 0 and y greater than 0, and 0 otherwise. A new random variable z is defined as z equal to e to the minus x plus y. Find the density of z, and you have 5 choices. And here's a solution. Because the region where the joint density is positive is a rectangle with sides parallel to the axis, and the joint density is a product of e to the minus x times e to the minus y, and these are densities of x and y respectively. X and y are independent and both have exponential distribution with mean 1. This means that the distribution of x plus y is gamma with parameters alpha equal to 2 and beta equal to 1. Alternatively, the density of w equal to x plus y can be found as a convolution of x and y. F sub x plus y of w is equal to the integral from 0 to w of f sub x of x times f sub y of w minus x dx. That's the integral from 0 to w of e to the minus x times e to the minus w minus x dx. And that just simply equals the integral from 0 to w of e to the minus w dx, and that's equal to w e to the minus w. And the reason, of course, is that this is not a function of x at all. It's a constant, so it's simply the length of the interval times e to the minus w, because the parts involving x cancelled out. And this is, of course, a gamma distribution with parameters alpha equal to 2 and beta equal to 1, or alternatively simply a sum of two exponential distributions, both with mean 1. Now, z is equal to e to the minus w, so that w is equal to minus the natural logarithm of z, so that dw over dz is equal to minus 1 over z. Therefore, the f sub z of z, the density of z, is f sub w of w that corresponds to that z times the absolute value of the derivative of the inverse of the transformation, and that's equal to minus the natural logarithm of z times e to the minus the natural logarithm of z times the absolute value of minus 1 over z. Okay. Well, e to the minus ln of z, then that's just z. And the absolute value of minus 1 over z is z, so it's z times 1 over z, so that cancels out. And what we're left with is minus the natural logarithm of z, or the natural logarithm of 1 over z. Now, remember what z is. Z is e to the minus w. Therefore, this was that w was any positive number, so that values of z are bounded between 0 and 1, because this is z is equal to e to the minus w, where w is a positive number. And of course, if you plug in w equal to 0, you get e to the 0, which is 1. And then as w increases all the way to infinity, e to the minus w declines, converges to 0. So it's a natural logarithm of 1 over z for z between 0 and 1, and that's answer D. Please remember this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.